So dear students, today we will discuss about linked list. Now what is a linked list? Now basically it is a linear data structure. So first of all you should remember that data structures, we have linear and non-linear data structure. Now linked list comes under the class of linear data structure. Now how can we define it? Now linked list is a linear collection of memory blocks which are known as nodes. Okay, so each memory block within a linked list are known as nodes, such that each of the block or node consists of at least two fields. So one of the field is known as info field and another field is known as link, or we can call it next field. So this is the structure of a single node. So we can call this is a single node, this one, which have two fields. One is info field and the second one is link field. The info field or information field we call info because we call it information. Now this field is used to store some information or some data element. Now we know that when we implement a data structure, our basic objective is to store some data element, and a linked list is a collection of memory blocks. So each of those memory blocks must contain some data. Okay, so therefore the memory block of a linked list, the memory nodes of a linked list has two parts. One of the part is info, that info part contains the data, and the second part, which is called link part, that contains an address, and this one is an address. So address of next node in the linked list. So link, that is contains address of the next node in the linked list. Is that clear? Now suppose we want to create a linked list containing, where we want to store name of 3 students. So how can we use it? So this is our overall logical view. We have a first node. The first node has two fields. One is info field and the second one is link field. The info field, in info field we have stored name of a student, and the link field contains address of the next node, and the next node again will contain name of another student. So in the info part of the next node there is the name of the student, let's say Suresh, and its link field contains address of the next node or next memory block, and in that next memory block there will be a info part as well as link part, and its info part contains name of a different student. Now suppose this is the last node, that means there are no other data available. So the link field of the last node contains a special value, and that value we call as null value. We call it null, N-U-L-L. Okay. Now when we create a linked list, we have to maintain the starting point. That means what is the address of the first node. So the address of the first node should be kept in a different pointer variable, and name of that pointer variable is start. So the variable start should contain address of the first node. So guys, I hope you understand the overall concept of linked list. So why we say it is a linked list? Because here the collection of data element are stored in different memory blocks, such that each of these memory blocks are connected with a special address fields. Okay, so why such a collection is called linked list? Because the collection of data items which are located in different memory blocks. See, these memory blocks are not contiguous, unlike array. So these memory blocks could be located anywhere in the memory, but all these memory blocks which contains data are connected with each other with the help of an address field. So therefore this entire structure is known as linked list. Okay, so this is what a linked list is all about. Now guys, how do we create a linked list? Okay, or what is the way to, what is the mechanism to implement a linked list? Now, from the discussion, you must be realizing that a linked list basically is a collection of nodes. So when we say node, then every node must have at least two fields. So when it is a collection of two fields, that it becomes, one single node is similar to a record structure because of the two field. For example, suppose I am saying this is a single node. Now this node must contain at least two value, and both of the value are of different category. One is info part, it's a data, and the second one is a link, or you can call it address. So these two data item are heterogeneous data item, they are not similar data item. So in order to store heterogeneous data item as a single memory block, we have a structure data type that we have already discussed. So now to actually implement a linked list, how do we implement linked list? Implementing a linked list, what we can do, we can simply create, to implement a linked list, we need to create a structure data type as follows. Okay, so I will create a struct like this, struct, let us give a name to that structure, let us call it node. Now how many members should be there in a structure? This structure data type must have at least two members. One of the member is for info field. See, this is info field, so we have to give info field, and for that info field we have to specify data type. Now what kind of data here I want to specify? So its data type must be given. So data type followed by info. Then second one, what is it? It is an address field. We call it, let us call it next, or you can call it a link. So second one is known as link field. But since link or next is an address field, it should be a pointer. So before link I have to write asterisk. Now my point is, what should be the data type of this link field? Now this is very critical, or this is very important, you should understand. Now link field, this one or next field, should contain an address. Address of what? Address of another node or memory block. So let us assume this is the memory block. Now these two memory block, the structure of these two memory block that we have created must be similar. So now this structure that we are creating this structure to reserve space for one single memory block. See, struct node. After creating this struct node, we have to declare some variables, or we have to reserve some spaces for a particular single node, this one. Now the second node, whose address must be placed here, the data type of second node, what should be the data type of second node? Second node also requires two fields. So it has an info field and it has also an link field. So its data type must also similar to the first one. So the second node must be again of struct node. Okay, so this pointer who will point to the second node, the data the pointer becomes a pointer to a structure that we have discussed in our earlier video, pointer to a structure. So this pointer shall point to a structure variable. And what is the data type of the structure variable? Same as this. So I will say the struct node should be the data type of this pointer variable. So because the name of the entire structure is struct node, then data type info part must be there, and then there is a pointer variable whose data type must be struct node. Let me give you an example first. For example, suppose I will create a structure like this: struct node int info. So now info becomes integer variable. Now I need a link field or pointer field within the structure. Now what should be the data type? To explain this, let us assume that I have created a struct node S1 and S2. So these are the two variables that I have created. So what is the structure of these two variables? Now this one, let's say S1, and this one, let's say S2. What I need, now S1 must have two fields, and I need here, this one is info part of S1 and this one is link part of S1. So I need value stored in S1 of info must be an integer, but the value that has to be stored in the link field. Now this one is info part and this one is link part. Here I want to store address of S2 because it is the next node. So how can I achieve it? I can write S1 dot link equal to ampersand S2. So since link field is a pointer field where I will store address of S2. So what is the data type of S2? Data type of S2 is struct node. So therefore data type of this link field should be declared as struct node. Okay. So see, actually in program we will not do like this, we will not create memory like this, rather we will use some dynamic memory allocation. But to create a linked list, for the timing you should understand that at least we need to declare a structure, and then we will create linked list in a different manner using dynamic memory allocation. So this is the basic concept of implementing a linked list. Okay, so there are other ways, like you can also implement a linked list using array, but that has very limited use. That is not a, you cannot take the full advantage of dynamic memory allocation. Okay, so main advantage of linked list is if you implement dynamic memory allocation is you can keep adding more and more number of nodes in the linked list whenever required. So we will discuss those concepts in our next class. Okay, so for the time being, for this today's video, what we discussed, what is linked list and what is the overall concept, and if we want to implement a linked list in the memory, what is the minimum things that I need? I need a structure data type. Within the structure data type, I must keep minimum two fields. One of the fields should be declared to store the information or to store the data, and the second field must be created so that it can contain address of next node in a linked list. So therefore the data type of the second field, the data type of the pointer, must be a structure of the same structure type. So entire structure is now actually known as self-referential structure. So this type of structures where there is one field, at least there is one field which is a pointer to the same data type, then this type of structure is known as self-referential structure. So it is known as self-referential structure. So to implement a linked list, we need a self-referential structure. Okay, in our next video we will do different operations or within a linked list. We will see the algorithms and programs for conducting various operations in a linked list. Till then, thank you.